Hello everyone, welcome back to RDCS tutorials. In today's video, we are going to discuss top 20 important DBMS MCQs for UGC NET Computer Science, TGCET and other competitive exams. Now let's start with question number 1. Which of the following is true about functional dependency? Option A, it describes relationship between tuples, it describes relationship between attributes, it describes relationship between tables, it describes relationship between database. So option B is the correct answer. It describes relationship between attributes. Now let's understand this concept deeply. Functional dependency. Functional dependency is one of the most important concepts in DBMS normalization. Okay, functional dependency describes the dependency relationship between innate attributes. The dependency relationship between two attributes. Suppose we have student ID, student ID, student name, and department is there. Okay, we have three columns in a student table: student ID, student name, and department. If one student ID, the student ID always determines exactly one student name. Okay, one student ID always determines exactly one student name. Then we will write student ID determines. Okay, this we call as this arrow symbol we call as the determines. It is nothing but the dependency. Student ID determines student name. When we call the student ID determines student name, when the student ID always determines one value with the student name. This means using student ID, we can uniquely identify the student name. So whenever you know about the student ID, immediately we can identify easily student name. Okay. Functional dependency is very important because it helps you the reduce redundancy. Reduce redundancy means the repetitions it will remove, the remove anomalies, the duplications also it will remove, the design proper the database structure. So it will design the proper database structure and it will perform the normalization also. This concept is mainly used in 2NF. That is the normal forms are there. We have 5 normal forms there. Mainly it is useful in 2NF, 3NF and BCNF. Okay, 2NF, BCNF. So without functional dependency analysis, database may contain repeated unnecessary data. Okay. So I will give one real-time exam. In college database, hall ticket number uniquely identifies the student name. Yes. So one hall ticket belongs to the how many numbers? One hall ticket numbers is belongs to only one student, right? There is no repetitions are there here. So if the two students are belongs to same hall ticket number, no, that is not possible. So here hall ticket number determines the which hall ticket numbers determines the student name. This we call as a functional dependency. Okay. So why other options are there? The correct answer is option B. It describes a relationship between the tuples. So functional dependency works inside the relationship between the attributes. It will not relationship between the tuples. Tuples are nothing but the rows. Attributes are nothing but the columns. Okay. And relationship between the tables are made using only the foreign keys and joins. There is no relationship with the functional dependency. The two tables, the relationship will describes only the joins and the keys. So functional dependency, there is no relationship between the database. Okay, it works only in a relational level. It is not work in a database level. Okay, so simple. I will give one remembering trick. Functional dependency means one attribute determines another attributes. Okay, now moving to the question number 2. A candidate key is minimal super key, foreign key, composite attribute, derived attribute. The correct answer is minimal super key. First understand what is a super key. Okay, first understand what is a super key. A super key is an attribute. Okay, na? We can call it as is an attribute or a combination of attributes. Okay, either it is a single attribute or the combination of attributes are nothing but the multiple attributes that uniquely identify the tuples. Again, I am telling tuples are nothing but the rows values, attributes are nothing but the column values. For example, same example, there is one student is there. This student we called as student is a relation. The relations are nothing but the table. Okay, student, how many columns are there in a student? ID, name, and phone number. Okay, there are three columns are there in a student relation: ID, name, phone. So if you take any column, for example, if I take name, can I identify these two values? No. If I take phone number, can I identify the name and ID? No. So this is not a super key. Based on one column, we cannot uniquely identifying the other columns. So it is not a super key. If we can add a ID as a super key, can we identify the name, phone number? Yes. For example, if you take an Aadhaar card, okay, na? ID is nothing but if you take an Aadhaar example, if anyone knows your Aadhaar card, then again, then another person can know the name of your Aadhaar card ID. They know. Yes, the name they will identify, the address they will identify, like village, they will identify your pin code also. So here Aadhaar card ID is nothing but the unique identification that we call as a super key. So same example in your student, take as a student ID like a hall ticket number. So based on the student hall ticket number, can we identify name? Yes, we can identify the name of the student. We can identify the phone number of the student. We can identify the address of the student also. So this we called as a super key. But name, for example, if I take the name, so sometimes the name is repeated or there. For example, there is some Varsha is there. So same person in your class, another Varsha is also there. So that's why we cannot take your name as a uniquely identified key. Okay. Of so here ID is the super key. So candidate key. So why candidate key? After removing unnecessary attributes, the minimal super key is obtained as a candidate key. So after completion of identification of super key, that minimal key we called as a candidate key. Okay, now what are the candidate key properties? Unique. The key should be unique and it is a minimal super key, and minimal is nothing but no unnecessary attributes. Okay, the option A is the correct answer. A candidate key is a minimal attribute. Okay, so foreign key. So why the foreign key is wrong? The foreign key create the relationship between the tables. It will only create the relationship between the tables. It does not uniquely identify the tuples. The composite attribute, it will be divided into the subparts. Okay. It can be divided into the subparts. For example, address is there. So in our address, only there is a city is there, what is your city and what is your village and what is your mandal, like that. There are some subparts are there. That subpart we call as a composite attribute. So derived attribute, It is a calculated from the another attribute. Directly we cannot identify the data. It will be dependent on another attribute. For example, age of from date of birth. If you know the date of birth, then we can identify the age. That we call as a derived attribute. Okay, the simple exam trick I will give. Every candidate key is a super key. Okay, every candidate key we call as a super key. Okay, but every super key is not a candidate key. Okay, every super key is not a candidate, but every candidate key is a super key. Okay, I'm going to the question number 3. Normalization is mainly used to option A, increase redundancy, reduce redundancy, increase complexity, reduce tuples. The correct answer is option B, reduce redundancy. Okay. First, understand what is normalization. Normalization is a process of organizing the database efficiently. Efficiently means the accurate data should be there. Whenever we apply the normalization, the table should be in a accurate, correct, and that we call as a efficiently. Okay. The main goal is for the normalization is we are reducing the redundancy and avoid the anomalies. So while updating or while deleting, while inserting the data, there is some duplications are there. That duplications we need to remove. Okay, na? First one is reduce the redundancy, and we need to remove the anomalies, and we need to improve the consistency. Okay, improve the consistency. This is the main important points for the normalization. Consistency. Okay, suppose same department name repeats 100 times in a student table. In there is one student table is there. Student table is there. Same department. In the students, there are different departments are there. In same department name repeats the 100 times in a student table. So what is the problem occur when we are updated we need to update in 100 tables. If we updated once, again there are 100 repetitions are there. So whenever insertion any data, this is nothing but the insertion anomaly. Whenever they delete the data, so one data is deleted, then again 100 data is also deleted. So this we call as a, while updating we will get some anomalies, while insertion we will get the anomalies, while deletion also we can get the anomalies. This is the problem occur we will get whenever the repetitions are there. Okay, the normalization. So how the normalization will work? The normalization, there is some problem is there. Problems, the divided the large tables into the smaller related tables, then we will apply the normalization. In a normalization process, we are dividing in the large tables into smaller related tables. Like that, there are different normals are there. One first normal from 1NF, 2NF, 3NF, BCNF, and 4NF, and the latest one is 5NF is also there. Okay. So we'll give one real-time example. In hospital database is there. Doctor details repeated for every patient creates the redundancy. Yes. There is no need for the doctor details for every patient. Yes. That will nothing but the normalizer. So why the normalization will work here? Normalization separates the doctor's table separate and patient table separate. So there is no need about the doctor name again and again, because only one doctor is there in a hospital. The doctor only treated the patients, every patients, right? So this we call as a normalization. So here normalization what will do? The normalization will do delete the repeated data. Okay, it will delete the repeated data. Now moving to the question number 4. Which SQL command is used to remove a table completely? Okay. Question number 4. Which SQL command is used to remove a table completely? Option A, delete, remove, drop, and erase. What is the correct answer? The correct answer is option C, drop. Okay, there are two commands are there for the deletion. One is drop command. It will remove the table structure. Okay, na? Overall the structure of the table it will be deleted. And the memory allocation it is also removed. Okay, na? Drop. It will remove a table completely. Based on there is some syntax here this for the drop table. So drop table drop table. So which table you want to delete? So then we will need to add the table name. This is the syntax for the drop table. After drop. So whenever you click the drop, there is no table exist. There is no longer the table is existed. Drop is which command? The drop is belongs to the DDL commands. In SQL, there are different types of commands are there. DML, data manipulation language, DCL, data control language, DDL, data definition language, and DTL, data transaction language. So this drop is belongs to the data what? Data definition language. Okay. Suppose a company no longer needs temporary employee data. The database administrator use what? Drop table. So the employee data should be deleted temporarily. Okay. Here delete is what? The delete will only remove the rows only. If you want to delete any rows in a table, we will use the delete option. The drop will delete the complete structure of the table. So here erase is not a SQL command. So here remove is also not a standard SQL command. Moving to the question number 5. Which acid property ensures all operations complete successfully or none occur? Option A, consistency. Option B, isolation. Option C, durability. Option D, atomicity. The correct answer is option D, atomicity. Okay, na? Atomicity means what? Atomicity means in a transaction, it will behave as a single indivisible unit. Okay, na? We cannot divisible by the other. It is indivisible unit and we cannot divide it into further. Okay, it is some unique one. So either entire transaction executes or entire transaction rollbacks. If any transaction is there, the transaction is entire executes or entire rollbacks. The partial execution is not allowed in a atomicity. This maintains the database correctness. So atomicity, it will not divide the indivisible unit. It will behave as a single indivisible unit. For example, there is some ATM machine is there. Okay, ATM. So everyone knows about the money transfer, right? ATM. The money deducted. There are two accounts are there. Account A and account B. So money deducted from account A. So the money deducted from account A and added immediately to the. So I want to transfer money from A to B. So whenever I transfer the money A to B, the immediately the account A amount is deducted. The immediately account B data is added. If the system sometimes if the system is crashes after deduction. So once the amount is deducted from the A person A, here the system is crashes by default. So after deduction, the rollback is occurs. The rollback is occur. Otherwise, the money will be lost. Here rollback is written. It is coming to the previous one. Okay. This is the atomicity. So why these consistencies and consistency, it will maintains the only the valid database state. It is some valid database state. Isolation, what? It prevents the transactions interference. Prevents the transaction interference. And what is the durability? It committed the data remains the permanent. Okay. So simple trick I will give the atomicity. Atomicity is nothing but all or nothing property. Okay. Moving to the question number 6. Deadlock occurs when? Deadlock occurs when? Deadlock is one of the most important and concurrency problem in a DBMS. So when the deadlock occurs when two or more transactions wait permanently for resources held by each other. Suppose there are two transactions are there, transaction T1 and T2. T1 holds the resources A, it will hold the which resource? It will hold the resource A and wait for the resource B. And T2 holds the resource B and it will wait for the resource A. Now both the transactions wait for, if T is waiting for B and T2 is waiting for the A. If we release T1, then only the A is available to B. If we remove the B, then only it is available for the A. Sorry, students. So where we left out in a deadlocks, right? So I understand. Again, I will give you some there. Imagine two people are there. They're in a narrow bit. The person one waits for person two. Person two move. A person two is waits for person one. So neither moves. This is a deadlock situation. If one person will move, then only they will go to that side or the person is come to this side. So if no persons are moving, they will in waiting stage only. This we call as a deadlock situation. Okay. Moving to the question number 7. Which key uniquely identifies each tuple in a relation? Okay. Foreign key, primary key, composite key, alternate key. The correct answer is option B. Okay. Primary key. Okay. First we need to know about what is a primary key. The primary key is a uniquely identifies every row in a table. So before we will discuss one example like a Aadhaar number. Yes. So if we take as a Aadhaar number is a primary key, based on these Aadhaar number, we can identify the personal details that we called as a primary key. For example, if I take a primary key as a name, can I identify all the details of the person? No. The name is repeatedly yes. So in a primary key, there are some rule is there. It should be unique and there is no null values are there in a primary key. Then only we will apply that column to as a primary key. Okay. The primary key, it will maintains the entity integrity. So again, I will give one another example. In college database, rule number is uniquely identify the each student, right? The two students cannot have same rule number. So rule number is acts as a primary key. Okay. So why the foreign key is wrong answer? The foreign key creates the relationship between the tables and composite key contains the multiple attributes and alternate key is a candidate key not selected as a primary key. Okay. When there are two unique identify columns are there in a table. So that time we will use the alternate key like a candidate key. Okay. So simple trick, candidate primary key is nothing but the uniquely identify the rows. Okay, I'm going to the question number 8. Who proposed the ER model? It is very important. Nowadays, they are asking the authors also. Who proposed the ER model? EF Code, Charles Babbage, Peter Chen, Alan Turing. The correct answer is option C, Peter Chen. So ER model means what? Entity relationship model. It stands for entity relationship model. Okay. ER stands for entity relation model. It was proposed by Peter Chen in which year? In 1976. Which was proposed by Peter Chen in 1976. So why this ER model is required? The ER model is used for the conceptual database design before actual implementation. There is some conceptual design is there. That conceptual design we call as a ER model before actual implementation. The main components of the ER model is entity, attributes and relationships. ER diagram, it is nothing but the visually represents the database structure. Okay, visually we are describing the database structure. For example, in hospital management system, the doctor patients are entities and it will treat is a relationship between them. So doctor and patient, there is a relationship, yes. So doctor and patients are entities and the relationship between the two persons are is nothing but the relation. Okay. So the Charles Babbage we know is the father of the computer and it is nothing but the Turing machines. No. So EF code is not a he proposed by the relational model. Okay, na? Who proposed the relational model? The relational model is proposed by EF code. But ER model is proposed by Peter Chen. Okay. Moving to the question number 9. A tuple in relational database is column, row, table and key. In first question I already discussed about the tuple and attributes, right? Simply you can answer. The correct answer is what? The correct answer is option B, row. In the relational model, the row means we called as a tuple. Then what is column? The column is nothing but the attribute. So what is this row? Each tuple represents the complete record. Okay. For example, in a student ID, the 10 is it. So this 10 we call as a row value that we call as a tuple. Okay. The column represents what? Column represents the attribute. So like a table, it is not a row and it is not a column. It is a multiple. It contains of multiple tuples. So key, it is uniquely identify the tuples. So simply you can remember tuple means row. Okay, now moving to the question number 10. Which command belongs to DML? So DML, it is nothing but what? Data manipulation language. Create, alter, insert, drop. So the correct answer is option C, insert. DML stands for data manipulation language used for the manipulating the data inside the commands insert, update and delete. Which command belongs to DML? When new student joins the college, we are inserting the command. Yes. The correct answer is insert. So we are manipulating the data. Already some data is there. Again we are adding that new data into the previous data. Here some manipulation is done. So that we call as a data manipulation language. So which one is the command? The insert is a DML command. Okay. And create is what? It is data definition. We are creating the structure. So that is nothing but the create is nothing but DDL command. And alter is nothing but will modifies the structure. Okay, we are modifying the structure. Drop is nothing but we will delete the table structure. So DML, it is nothing but DML, we are manipulating the data. So here which one we are manipulating data? Using insert, we are manipulating the data. So the correct answer is insert. Okay. Now moving to the next question. Question number 10. SQL stands for very basic question. Okay. Structured query language, sequential query language, simple query language, standard question language. The correct answer is what? The correct answer is option A. Structured query language. SQL stands for structured query language. It is used to communicate with the relational database. Okay, na? It is used to communicate with the relational database like functions. We are creating the tables, we are inserting the data, we are retrieving the data, we are updating the data, we are deleting the data. So this we call as a structured query language. So when banking software retrieves the account balance, that SQL queries are used. Okay. In a banking system, real-time example, banking system, we are using SQL. Okay, S stands for structured, Q stands for query, L stands for language, structured query language. Okay, moving to the question number 12. Cartesian product of relations R and S contains sum of tuple, difference of tuples, product of tuples, minimum of tuples. The correct answer is option C, product of tuples. If relation R has m tuples, in a relation R has how many tuples? M tuples, and relation has S as n tuples, then we are calculating R cross S. Okay, na? That multiplication we call as a Cartesian product. R cross contains how many tuples? M cross n tuples. If there are three teachers are there, three teachers teach of four subjects. Possible combinations what? 3 into 4, that is nothing but 12. So this we call as a Cartesian product. It is nothing but product of two tuples. Okay. Question number 13. Lossless joins ensues. No data loss after decomposition, faster execution, duplicate rows increase, more redundancy. So the correct answer is option A, no data loss after decomposition. Lossless joins what? Lossless joins ensues the original relation reconstructed perfectly after decomposition. If we reconstruct the table also, we will get the perfect decomposition that we call as a lossless join. For example, the student table is there. Okay, this student table is divided into separate. Student details are separate and department details are separate. So after joining, the complete original table should be written. So that is nothing but the lossless join. No data loss after decomposition. Now question number 14. Referential integrity is maintained using candidate key, primary key, foreign key, super key. The correct answer is foreign key. Referential integrity is nothing but the foreign key. It maintains the valid relationship between the tables. It maintains the valid relationship between the tables. So in order table, there is some customer ID is there. The customer ID must exist in a customer table. Okay, that is nothing but the reference. We are taking the main table as main table. Then there is some subpart table is there. For example, there is some order table is there. Order table. So in a order table, there is some customer ID is there that exists in which table? Customer table. So what is the reference here? Order table is we are taking as a reference table. Okay. And question number 15. BCNF is stronger version of what? BCNF is stronger version of 1NF, 2NF, 3NF and 4NF. The correct answer is option C, 3NF. So BCNF means what? The full form of BCNF is Boycott Normal Form. Okay? Boycott normal form. So it will remove what? It will remove the anomalies not fully handled by the 3NF. In 3NF, we are removing the anomalies, but if the 3NF there is some disadvantage is there, so that disadvantage we are fulfilling with the BCNF. Okay. There is in a faculty course allocation is there is some dependency problems are there. That dependency problems are solved using the BCNF. Okay. So 1NF and 2NF is the lower normal forms, and 4NF it is handles the multi-valued dependency. Okay, we will discuss the important concept normalization for normal forms in our upcoming videos. Moving to the question number 16. Which operation combines tuple from two relations? Physical table. What? Which operation combines tuple from, sorry, which operation combines tuples from two relations: projection, selection, join, and division? The correct answer is option C, join. Join is nothing but the simple, you can remember as a trick, combines. Whenever you combine the two relations, that we call as a join. The join combines related tuple using the common attribute. There is some student table is joined with which table in a student table? We are join the marks table using the student ID. Okay, like that. So projection is select the columns. So when we combine, we'll get the data that is nothing but the tuples. Join is nothing but combines is nothing but the join, and the columns projection select the columns and selection select the rows. It selects the only rows and it selects the combines the only columns, and the join it combines related tuples in a common attribute. So in there is two tables are there, which column is common, that column we are combining using the join. And division, what is the division? Division we are dividing, we are decomposing the tables into separate tables. Okay, moving to the question number 17. A view in SQL is physical table, virtual table, temporary database, and schema. So view is nothing but the correct answer is virtual table. Correct answer is option B, virtual table. View is nothing but the virtual table created using the query. So whenever you execute the view query, we will see the data. We will not do anything, just we are seeing the data. Okay, for view purpose only. If you want to view any employee names or any HR department without the salary details, just you will see the employee details. Just we are seeing the data, that is nothing but the view. So next question number 18. Schema represents database design, data value, row count, query output. The correct answer is option A, database design. Schema represents the database. Schema is nothing but the structure of the data. Schema defines, we can also call as a logical structure of the database. Logical structure of the database we called what? The logical structure of data we called as a schema. It is nothing but simply, if you want to construct any building, before that what we will do? We will prepare some blueprint, right? That blueprint we call as a scheme. Okay. Question number 19. 1NF removes was partial dependency, multi-valued attributes, transitive dependency, functional dependency. The correct answer is option B. It ensures atomic values only. The correct answer is option B, multi-valued attributes. If phone number column contains, there are two mobile numbers are there. So 9876 like that, or 9123 is in together, we are split into the separate row. In 4-number column, there are 2 values are there in one column, 2 rows values. So we are divided into like a separate rows data. So here we are adding 9876 and here we are adding 912. So we are divided. So that multi-valued attributes we are removing. So that we call as a 1NF. It removes the multi-valued attributes. In a column, there are 2 values are there. We are divided into single columns that we call as a 1NF. So here, what is a partial dependency? It will remove in a 2NF. Partial dependency removes the transitive dependency. Transitive dependency is for the 3NF. Partial dependency is nothing but the 2NF. Okay. So 1NF removes the multi-valued attributes. Now, question number 20. Serializability in DBMS is used to ensure what? Serializability in DBMS is ensured to what? Data redundancy, transaction correctness, query optimization, and data compression. Which one is the correct answer? Serializability. So there are important methods are there in a transactions. What is that? The deadlocks are the deadlocks. There are 3 methods are there in a deadlocks. Deadlock prevention, deadlock avoidance, and deadlock corrections are there that we will discuss in further video. And there is some important concepts are there. Locking methods also there. 2-phase locking methods. So like that shrinking methods and growing methods. So there are different components. Topics are there in a transaction management. In that transaction management, the question is related. This question is related to the transaction management. Serializability in DBMS is used to ensure what? Data redundancy, transaction correctness, query optimization, data compression. So the correct answer is this belongs to which concept? Transaction correctness. So now to understand this concept, serializability is one of the most important concept in which transaction management. Okay, and concurrency controls also there. If multi-user database is there, many the transaction execute the simultaneously. Whenever multiple transactions are there, that multiple transactions execute simultaneously. When multiple transactions are run together, there some problems will occur. So which problems? Inconsistency data, incorrect update, and lost data, dirty reads. There are different problems will occur. So that problems we are avoiding using the which concept? Serializability. Okay, serializability. First understand what is in a serial execution. So one transaction completes fully before another transaction starts. So then the 2 transactions are executing at a time. So if one transaction T1 is complete, then only we will go to the transaction 2. So one after another. So this we called as a, whenever that completely T1 transaction executes only, we will go to the T2 transaction. So this will give the correct output because transaction do not interfere with each other. So DBMS allows the concurrent execution for better performance through which concept? Through the serializability. These are the 20 important questions of DBMS. If you found this video is useful, please like, share and subscribe to RDCS tutorials. Thank you for watching.